Welcome back, ladies and gentlemen. This is section 10.3. It's all about chords today. I'll get to your exit question in just a moment, but I'm going to start off in sketchpad today. Up on the screen, you'll see a circle. I'm going to do some interesting things to it. Firstly, we have a circle. It already has 1 point on it defining its radius. I'm going to put a second point on it, and I am going to connect those 2 points with a segment. You should remember from section 10.1 that segment right there that I called a segment is a chord in this circle. What I'm going to do to that chord is I'm simply going to place a midpoint on it. So I'm going to construct the midpoint of that chord, and then I'm going to draw a perpendicular bisector from it. So basically I'm going to take that segment and construct its perpendicular bisector. Guess what happens? It fires a line right through the diameter of the circle. That's more than just a little coincidental. That will always happen no matter which chord you draw on no matter what size circle you have. This is quite handy. Check this out. Pretend you had a circle, except you had no idea where the center was. So we're just going to hide that point. Check that out. I have a circle. I have no idea where it is. All you have to do is put 3 points on the circle, and you can find the center of that circle. Check this out. Connect 2 points to create a segment. Do it again. Boom. And then just simply construct the perpendicular bisectors of each one of those. They will each shoot out a diameter from them, and where the diameters intersect is obviously the center of the circle. So if I do that, construct perpendicular line. If I do this, construct perpendicular line. And with any luck, that right there should be the center of our circle. And if I display the hidden circle, again, look at that. It just pops right up right where it was. This always works no matter what size circle, no matter where we draw those 3 points along the circle, it will always intersect in the middle of the circle. The second sketch I want to do for you today is another relatively simple one. Here I have a circle with a diameter drawn. I am going to simply place a point on the diameter and construct a perpendicular line from that. When I do that, I create a chord from here to here. And you might notice that it looks as if that diameter is perfectly bisecting that chord, and you'd be absolutely correct. If we took and measured the distance from here to here, it should be the exact same distance as the distance from here to here. And again, that should work with any circle, any diameter, any perpendicular line going off of that diameter. Should work just fine. All right, let's transfer back to our normal slideshow. Very quickly then, there is your exit question for the day. As I've just demonstrated in Sketchpad, here are your theorems today. I'm going to go a little bit out of order because of what I showed you in Sketchpad. This is theorem 10.4, and it simply says that if one chord in a circle is a perpendicular bisector of another chord, then that first chord must have been a diameter. So in other words, if you bisect a chord with a segment, that segment or line or whatever will be a diameter of the circle. 10.5 is very nearly the converse of that, but it doesn't quite stand alone on its own, so we have to let it be its own little theorem. If a diameter of a circle is perpendicular to a chord, then that diameter bisects the chord. So if you have a diameter that is perpendicular to a chord, then that diameter must bisect the chord. Going backwards a little bit, here's theorem 10.3, and it's a pretty simple one. It says that if you have 2 congruent arcs in a single circle or in 2 congruent circles, then the corresponding chords must also be congruent. So you have to have congruent circles or in the same circle for this to happen, but it totally works. The last and final theorem for the day is theorem 10.6, and it says that in the same circle or in congruent circles, If you have two chords that are equidistant from the center of the circle, then those two chords must be equal in length. Now remember that we define the distance between a line and a point to be the distance between that line and a point on a perpendicular path. So this has to be a perpendicular path right here in order for this to be true. However, there is some added strength of this theorem that it is an if and only if statement, just as 10.3 was. So this is an if and only if statement, as is 10.6. 10.4 and 10.5, not quite if and only if statements. They're close, but you need to add some more conditions to them to make them work all the time. Let's jump into another definition here. Definition of an arc bisector. So we've had segment bisectors and angle bisectors, and now we have an arc bisector. And it simply says that CY is an arc bisector if and only if arcs XY and YZ are both adjacent and congruent. Simple enough. And on circle C, if we're doing the nomenclature correctly. Jumping into our first example, here is the drawing. The measure of arc AC is 150 degrees. It's a minor arc. Find the measure of arc AB. You've also got some given information, distances in the circle in the drawing itself. The distance between A and B is 9. The distance between B and C is 9. Therefore, those two segments must be equal, and if those two segments are equal, those two chords are equal, and if those two chords are equal, those two arcs are equal in length or in central angle measurement, and thus we can fill in all the blanks like this. Okay, so we have the measure of arc AB eventually has to be the measure of arc BC, but notice that it took a little bit of work to do that. We had to go from a distance using an equal sign to a segment congruency to an arc congruency, to an arc measurement equivalency. So there's a little bit of work to do there. If you ever find yourself doing a proof, I don't think I'm that mean this chapter, but you never know. Next up, we have to find some way to relate all this information. So once we know that arc AC is 150, we've got arc AB and BC, which are actually the same arc, covering the rest of the circle. So therefore, 150 plus AB plus BC must equal 360. And we just plug in what we know, 150, and the measure of twice AB should take up the slack in that circle. And then all we have to do is solve. Divide by 2, 105 degrees, done. Next one, very cool problem. Where do you put a sprinkler to hit all three of those trees on the very end of the sprinkler's swath? This is a very cool problem because it has no numbers in it. The answer is a construction. And this is just like the problem or the sketch that I had before where we didn't know where the center of the circle is. So we need to find the center of the circle. To do that, we're going to use this idea that if we construct a perpendicular bisector, that perpendicular bisector should go through the center of the circle. Our goal is to get all three trees on the circle somewhere. This connects two of them to the single circle. So if we put another tree, hopefully somewhere over here, and then do a perpendicular bisector of it, it should go through the center too. Therefore, if we do that to this drawing, draw two perpendicular bisectors from the middle of these two pairs of trees, or a trifecta of trees, we should go right through the center of the circle. So I'm going to take that drawing up above, and I'm going to convert it into boring geometry drawing. Look at that. Much less interesting looking. Much better. Okay, so moving on. We want to construct the perpendicular bisectors of that. Remember to do that with a compass. You swing an arc above and below. You connect the intersections, and bam, you've got a perpendicular bisector. I just did it by eye, like that. And then I, of course, have to do that for segment AB as well. And hopefully, if I've done this fairly accurately, I can take my circle tool over here, and I can draw a circle from where this drawing says the center of the circle should be. And I should go to any one of the 3 points, and hopefully that circle is going to go through all 3 points. And you can see that I'm a little off, but you can imagine that if I did that in sketchpad, it would be dead on perfect. There's your assignment for the day. I'll see you next time.